Hello everyone, let's look at today's Leetcode problem 1061 lexicographically smallest equivalent string. Before starting this problem, let us look at a motivational quote. Life isn't a race against others, it's a journey of self improvement. The only competition that truly matters is between the current you and the past you. Every small step you take, whether it's studying 10 minutes longer, waking up on time, or understanding one more concept, is a victory over your older self. It shifts focus from envy and or pressure to internal discipline and consistency. So there are quite a few things to understand. So whenever we are going in a long journey or taking up long uh, courses or anything, so it will always be consistent and in slow, disciplined effort. And every day we should increase the level of work which challenges us. Maybe taking up one more extra small assignment or maybe something small of such nature. So it it will be a comparison to our own self, and nobody should be compared with what we are capable of doing. Yeah, so let us understand the problem statement here. So you are given two strings of the same length s1 and s2 and a string base str. We say s1 of I and s2 of I are equivalent characters. For example, if s1 is equals to abc and s2 is equals to cde, then we have a is equals to c, b is equals to d, and c is equals to e. Equivalent characters follow the usual rules of equivalency relation. Reflexivity, the same string a is equals to a or c is equals to c or anything like that. And symmetry does mean if a is equals to c is equals to a. The same thing is given here. And transitivity is if a is equals to b and b is equals to c, then a will also be equal to c. That's the understanding, since b is somehow related to c. Okay, so there is also an example given in this problem statement. Let's say S1 is ABC and CDE, and a base string of ACD. So we see that out of these three characters, B, A, and out of these three characters, B, D, C is the resulting output. So B is the resulting output, and whenever we see C, we also need to take into consideration A. So it would be A, B, A. So that's the output that we might need to return if we are given with a base string of this and then characters S1 and S2 here. And let's say if we take this example where S1 of ABC or ACD and AAB are equivalent strings, and we are given with two strings like EED, then we might need to consider uh, replacing this with A. And since we also see A with C, so this should also be uh, A, while out of D and B, the lexicographically smallest string is B. So AAB is the final result that we see here. Okay, so we need to return lexicographically smallest equivalent of base string. So let us look at a simple example here, Parker and Morris and base string parser. So let's say example 1, which says Parker, Parker, and Morris, Moris, and these are the S1 and S2. S1 and S2 characters, and base string is this, where str and parser is the final output, Parser, right? So okay, let's say this is our string, and let's see what are the different characters that we need to consider. So here we need to consider PM, and we don't see P and M in any of the other set of characters relating to S and M. So we can decide P and M out of P and M. We need to pick a lexicographically smallest string. When we look at A and O, here A is related to O, and considering A and O, do we see A and O any other place? I don't see A and O being repeated in any of the other places. While if we see R here, so R is seen here as well, and K is also related to it. So R might also be related to K. So these are the two strings that, and again R is related to S as well. So R is also related to S, so which we need to consider out of these three. And whenever we see RK of S, then we need to replace it with a lexicographically smallest string. So that's the whole idea. And here we see character E and I, which is out of E and I, we might need to pick one of it, and that's the whole output. So if we need to look at what has been given here, M and P, we pick M, and M, A, K, K, A, E, I, E, I, K. So this is the final output that we see, M, A, K, K, E, K. So M, A, K, K, E, K. So that's the output. So the other two set of examples are also more of the same, where uh, we can also take a look at this example, which is Leetcode, which is this way, and programs and source code. Okay, so let me rewrite it here. So LEETCODEPROGRAM and S, and source code SOURCECODE and E. So yeah, so these are the two set of extra strings which are there in the base string. So let's see what we have here. So L and P, we do not see L and P in any other occurrences, so we might want to decide L and P uh, for the consideration of picking which is the smallest character out of these two to get the lexicographically smallest part of characters for our output string. And when we see E, we see multiple things relating to E. E is R, R, O. E is also related to O. R is also related to C, C, and uh, we see O here, which again gives us A, and E is also related to S. So these are the set of characters, and this is the major part here. So anywhere we see these set of characters, we can display uh, A as the smallest character. So, and here we do not see T and G anywhere, so this can be T and G, and these can be already replaced with a lexicographically smallest string that we have here, and it would be D comma M in the last character. Okay, so so if we see A SOURCE out of L, S1 S2 LP LP, we group the equivalent characters in as LP, thus all the string characters except U and D. Except U and D are transformed to A. The answer is A U D. Okay. So U and D are the two characters which do not have any matches. So Moving base string is changed to D. Okay, so the order. Okay, so here, as we understand the explanation, so out of we group the equivalent characters from S1 and S2 as these set of characters, and thus all letters in base string except U and D are transformed to A. The answer is A U A D A. Okay, uh, we get some understanding from this one. So let us look at how we can approach this problem. So first thing is we look at all of the characters either from the string S1 and S2 as some sort of having a connection, and we build a graph uh, where we consider indexes as set of characters, and we might replace it with the connected set of characters between S1 and S2. So let's the first step that I can say is graph creation, where we create a graph with an adjacency list, and yeah. Next thing is uh, using DFS, we find some sort of a connected set of components. Let's say if at character I with S1 and S2, we can build an adjacency list. But to find the connected components, when we do a DFS, we can get what are the different characters in the string at different positions which are related or connected based on the transitivity rule, right? So connected components can be found out based on DFS. That's one thing. And third thing is creating mapping. Each components keep tracks of small characters in that group. Okay, so next thing is out of these set of connected components, we uh, create a smallest uh, character from the connected components. And fourthly, we transform the base string to the expected output based on the check with smallest characters. Okay, so I would, uh, if we need to have some sort of an thinking around how we will build our graph first thing. So let's say we create a graph which might be some sort of an adjacency list, and then we say characters from 0 to 26 would be added into this graph as an adjacency list, and we create a set for each character where it might be having set of connected characters, and we loop over uh, either s1 and s2, s1 or s2 and length, and then we add graph of s1 of I dot add to s2 of I, and similarly we do the same thing here. And this would be one block where we would populate all the graph edges, and once we do that, we before we keep track of a DFS where we send in certain a node and a component array in our next uh, set of actions. So let's say this would be our second step. So in our second step, in the DFS, we might also want to have a visited array or some sort of an hash map. So we will mark each, after each node we mark them as completed, and we uh, populate the components with the node that is pushed. It would be of a character, right? And we explore the next set of characters. Explore next characters that are connected uh, in different parts of the indexes. So that's about the DFS. And let's say in the third step, we so we perform DFS for 0 to 26 characters, and that means we would go from A to Z, and we would uh, get the components for each of the characters. Component of array, which a specific character, let's say A is related to some example, A might be related to E, T, or anything, right? So based on the example that we get, we build this character, and later we also calculate the smallest character from this. Smallest character from this, and okay, so that's about it. And then in the fourth step, we can simply map the base string characters to uh, the characters map, and yeah, so that would give us the result that we are looking for with the lexicographically smallest result. So let's go to our Leetcode editor and try solving this problem. As discussed, so first we will be building the adjacency list for the graph, and one of the things that we know here in solving this problem is all of the characters from S1 and S2 will be lowercase characters. So that's an given assumption in the problem statement. So we populate all the values for uh, the graph with the connected edges with each character considering from either S1 or S2 strings. And let's say this is S1. Yeah. So since this is a set, it will always be a unique set of values always. Okay. So this would build the graph, and let's also have two new constants, one for tracking a visited So yeah, now uh, let us build a DFS solution here, which would take a node and a component, and we also mark at each iteration we mark the visited to node and component. And from here we also explore the next set of characters, and we explore the neighboring elements as well, and we populate the components array. Okay, so this would this would give us all the components or the related characters with a specific character that we send in for TFS. And yeah, so next thing is we need to initiate the DFS for all of the characters. So we start the DFS for a specific character, and also we send in this components array, which gets populated with all the related uh, characters for a specific character that we are looking for with DFS. And we also calculate the smallest uh, character for the for the lexicographically smallest equivalent of a specific character group, and we get that with this way where we sort the characters and we take the first character. Okay, we do it this way, and from here we iterate over C of components. So with each character map that we have here, smallest character map, we insert all the related characters that are seen, and we add the smallest character just so that we can replace the base string and build the resulting array as per the problem requirement we. So this is our base str from which we check each of the character and return the lexicographically smallest character using the char map that we have just populated, right? So okay, so after this we just can simply return the result, and that should be our final answer. Okay, let's try submitting the solution. NEIGH. Okay. Okay, as you see, the solution gets submitted. If we need to understand the time and space complexity of this solution, so we are creating a open graph with the strings s1 or s2. So n would be of n, and we are doing a DFS for all the characters, that is 0 to 26 with this way, and that's one thing. So, and we are also having this specific for loop which is iterating the base character time. So we can say uh, time complexity would be length of s1 or s2, since s1 and s2 has the same length and base string has a different length, so we can consider length of either s1 plus s2, s1 or s2, and the length of base string. So yeah, that would be the time complexity, while the space complexity of the solution would be O of n, because we are not really storing any other uh, variable data, and we are having 26 set of graph nodes with adjacency list, and the DFS operation is also happening uh, based on the number of characters 0 to 26. So yeah, uh, that's about it. Thanks for watching my video. If you found this video helpful, please like and subscribe to my channel. Thank you.